All right, so the other day when we started talking about doing stoichiometry to the volume of a gas, we said that 1 mole of gas would fill 22.4 liters if we're at STP, which remember was standard temperature and pressure. So whenever you're doing any conversions that tell you that the gases were kept at STP or they're going to end at STP, we're using the 22.4. Okay, that's the perfect standard temperature pressure conditions. But we don't always have standard temperature and pressure. We don't always have perfect conditions. So what we need to know is what's called the ideal gas law. And the ideal gas law is PV equals nRT. Okay, and this is going to be on page 434 in your book. If you want to go through and read the section on ideal gas laws, you're more than welcome to. You're going to need the chart on page 435 because this is the chart that's going to give you the constant for R. So let's talk about what PV equals nRT means. P is going to be the pressure. Okay, and earlier this year we did pressure when we talked about the gas laws like Gay-Lussac's law and Boyle's law and Charles's law, and you were able to convert pressure. So you're still going to need those conversions like the 760 torr is 1 atm and 14.7 psi and those kind of things. Okay, so when PV equals nRT, we're talking about P for pressure. Volume is going to be the V. Okay, and our volume on here needs to be in liters. So if you get one that does milliliters, then you're going to have to convert it over. So in the lab this week and what you started on Friday, we captured the gas inside the graduated cylinders that were 1 liter. That's so many milliliters. It's 1,000 milliliters, and so you would have to change that over to how many liters that would be. Okay, I'm going to take N here, and N for what you're going to do today is going to be the number of moles of the gas that you have. Okay, the number of moles. And so we can take grams to figure out how many moles are in a substance. We've been doing those molar conversions for a while. R is what is called our gas constant. And this is why you're going to need that chart on page 435. There are different things for the gas constant. There's 0.0821 if you are talking about liters times atmosphere over moles times Kelvin, which is going to be the temperature. Okay, there is 8.314 as a gas constant if you're talking about liters times kilopascal. So notice in this case our pressure is in kilopascal to moles times Kelvin. And then we have 62.4 liters times millimeters of mercury, if that's our pressure, over moles to Kelvin. Now, a lot of people will just make you go to either the 0.0821 every single time or the 8.314. You have these options. So wherever you want your pressure to be, you can go with it. So you may not have to convert your pressure if you have these 3 things. If you don't and you just have the 0.0821, then your pressure is always going to have to be in ATMs. Okay, totally up to you what you do. If you want to always go to the same gas constant, you're more than welcome to. All right, and the last one, T, is going to be temperature, and this is going to be in Kelvin. All right, so our temperature is going to be in Kelvin. So remember, to get things to Kelvin, you're going to have to get your items into Celsius first, okay? And so that's that difference of the 273. So like 0 Kelvin equals negative 273 degrees Celsius.